Yes, hi Akshay, good evening. Good evening, Swati.
Good evening, sir.
Good evening, Hatira.
Good evening, sir.
Yes, Abhishek, good evening. Yes, Omkar, good evening.
Excuse me, sir.
Yes, Hatira.
Sir, I have some doubts on that linear regression assignment, sir, on the community.
Tell me, what is it out?
Sir, that placement data assignments, there is no relation between the independent and dependent variables, sir.
How come?
Means it's minus 0.026 that the relation is showing, sir. Both the CGPA and placement.
A relation is minus. That's fine. Okay.
That is
Minus
close to zero, right, sir?
minus 0.26, right?
Minus 0.026, sir.
Minus 0.026. Okay. So if that is the case, then you can skip that regression. Else, what you do is just for the sake of applying, I mean, practice, you can apply that linear regression, simple linear regression.
Okay, sir. Then, sir, that marketing data assignment, there
Uh-huh.
is a problem of multicollinearity, sir.
So there is if there is a problem of multicollinearity, then you have to delete the column. I mean, for example,
Sir,
let's say,
actually, which column I have to delete, sir? There are so many multicollinearity problem is coming, sir.
see, you have to delete the one which has very less relation with the target.
Sir, if I delete one variable also, then also there will be multilinearity problems.
So see, for example, let's say there are four columns and one target. So, for example, these two are having a multicollinearity problem, and these two are having multicollinearity problem. So now what you do is you check out of these two, which one is the least relation with a target. So if this one is the least relation, delete this. Then this one among these two, check the relation with the target. This is the least, then delete that. So keep these first and third and target.
Sir, I am still confused, sir. Can I share my screen, sir?
Okay. Yeah, share your screen.
Can you see, sir?
No,
No.
not yet.
Okay. 1 minute. Sir,
Yeah.
this is the heat map coming, sir.
Okay. So
So here,
0
that
point.
TV and social media, everything having relations, sir. That independent relations.
Show me I mean, relation heat map. So TV. Just hide this. Click on the hide option there. So sales TV one. That is fine. Sales radio 0.86. Fine. So here social media and TV. So delete social media because
Sir,
sales
if
with
we
TV.
delete social, yes,
Uh, Tell me.
if we delete social media also, there will be a relation with the radio and TV, sir.
Radio and TV. 0.87, 0.87. Right. Then you need to delete radio also. Radio also has to be deleted.
Then TV and sales only we have to do.
Yes. You can,
Okay, sir.
what
Okay.
else you can do is you can keep this one, social media, and delete only radio, because social media is 0.5. So for this problem, you can say that 0.5, I'm considering it as a less relation. So hence, maintaining social media, and try to
Okay.
see that.
Then this social media and radio 0.61, that also okay, no, sir?
Social media and radio.
Yeah,
Radio, I told you to
0.61
delete.
relation.
I told you to delete that, na radio. Delete radio, keep TV and social media and sales.
Okay, okay, sir.
Right.
Yeah, okay, sir.
You can stop sharing.
Okay, thank you, sir.
So I am assuming that all of you have gone through the Saturday's recordings. Okay, so most of you have not been there on the Saturday's class. So I'm assuming that. All right. So let me just share my screen. Okay. So today's data sets you can find in this particular link. So this is the link for the today's data sets. Let me launch my Jupyter notebook. If you have not gone through Saturday's session, please go through by today or tomorrow, because you can see that we have discussed quite a good amount of concepts in there, some new concepts. Okay, so hence, okay. So first, I will start today with this concept of pipelining. Okay, I'll say rename this, and I'll call it as pipelining. Okay, pipelining. So now, what is pipelining is, see, when you are studying, or when you are applying your machine learning project, so you have 8 steps that you already know by now, right? So step number 1 is importing the libraries, then step number 2, step number 3, like that you go on. Okay. So in that, if you talk about step number 3, so it is like performing missing value treatment, then sorry, performing missing value treatment separately for numerical columns, and then there is a separate missing value treatment for text columns. Okay, so I will write that here, so that will help you to get it better. Okay, so step number 3 in ML process, so we can say it as, so what we do, we basically do missing value treatment, missing value treatment, treatment for numerical data, and for text data. Okay, so let me just keep this uh, text data in an Excel. Okay, so missing value treatment for text data. Then what we do is we do feature scaling for numerical data. Then what we do is we perform feature encoding for uh, text data. Okay. See, in the last week of your machine learning, so you will also learn something like outlier analysis and all, feature selection, outlier analysis. So those things also will be included in this step number 3 only. Okay. So now just check this. So there are somewhere around 4 to 5 steps that you have to do that every time in the step number 3. Okay. So it is a repetitive step. You can see that it is a repetitive step. Now what we do is, what is the concept of pipelines here is using pipelines, using pipelines, we can automate this process. We can automate this process, okay, of the above 4 to 5 steps. Okay, 4 to 5 steps or whatever steps is all the above, all the data. I'll say instead of 4 to 5 steps, of all the data pre-processing steps. Okay. So what is the advantage of this? So advantages. So for example, let's say you are working on data. So that is the data is available to you. For example, let's say of the August month. Okay. For the August month, you have complete data available with you. Now, exact same steps. So step number 1, that's in the step number 3. So 1, 2, 3, 4, whatever we have written there, you have to apply it on the next month data also. For the September month data also, you want to apply the same steps. So now what happens is, since you have created, you will have created this pipeline, you can just pass your data to through that pipeline. What that pipeline will do is, it will apply all the 4 steps in order and give you the final output. So once we do that, you will understand that better. Okay. So see this. I'll just say start with loading all the libraries. So step 1. Okay. So is loading all the libraries. Import pandas as PD. Import numpy as np. Import matplotlib dot pyplot as plt. Import tborn as sns. Import warnings dot filter warnings. I'll say ignore. So these are the few libraries that I always will include. Then step number 2, load the data. Data is equals to pd.read underscore csv. So what data I will be considering here is, so I will consider this loan feb, loan underscore feb dataset. I'll say loan underscore feb. Okay, so let me just check the spellings. Yeah, it is F is capital. Feb.csv. Say data.head. So you can see this. This is your loan Feb data, February data for loan. Okay. Now, if you just check, so if you see this, that you have some 614 customers data available with you, and there are 13 columns in the data. 1, 3, 13. Okay, so then we go to step number 3, which is data pre-processing. Step number 3, data pre-processing. So I'll say data dot is null dot sum. So you can see that the data is having good amount of missing values in both text columns also, as well as in your numerical columns. Okay, so let's write that observation. Observation. So gender. Okay, so first one, gender. Then I'll say dependent size. Dependence, yes. So dependence is not a thing. Okay, so let me just check that. All right, fine. Loan amount term, credit history. So gender, you have dependents, self-employed, self-employed, yeah, self-employed. So I'll say self-employed. Okay, are text columns having missing values. Then remaining everything. So like dependents, you have loan amount, you have loan amount term. So let me just copy this. Is that here? Loan amount term, credit history. So all of these are numerical columns. Numerical columns having missing values. So what I'll do, I'll just do missing value treatment. Say missing value treatment. Let's say for married. Okay, married is also a column. Okay, yeah, yes, married is a column. So let's include that here. For numerical data. Numerical data. Okay, so I'll say from sklearn dot impute import simple impute simple impute. Then I'll say simple underscore imp is equals to copy paste this simple imputer function. So copy this and paste it here. So this is my simple imputer. Okay, so I will say the strategy that I will use is strategy is equals to median. Okay, so it is selected. Now just check this. Okay, so if you see this data, loan amount. Okay, so loan amount is proper numerical data. So you can apply median over this. But if you just check these things, loan amount term and credit history. So see this, even though they are numerical, what you can see is 360 means 360 months. Okay, so what I want to try to show you here is even though the loan amount term and credit history column looks numerical, median will not be a good strategy. Mode strategy will be a good strategy on this. Okay. Yeah. Only on this loan amount column, we will apply median. For these two, even though they are numerical, we will go for mode imputation. Mode imputation. And then these things, the dependents, marital status, and gender. So we'll go for mode only. For them also mode treatment. Is this clear? What I want to. Yes, clear. Fine. So I will say, yeah, all right. So I will say data of loan amount, okay, is equals to simple imputer dot fit underscore transform data of loan amount. Okay, then I'll say data dot is null. Okay, dot sum. So if you execute this, so you can just check that loan amount, the missing values which were which we had earlier have been removed. There are no more missing values present in your loan amount column. Now again, I will say missing value treatment for with mode strategy. So I will say from sklearn dot impute import simple imputer. Okay, then I'll say sim underscore imp, or I'll just say si is equals to simple imputer. Copy that, paste that here, and strategy is equals to mode si. So I'm using a mode strategy here. Then I'll say data of all the column names. So gender, then we have dependents, then we have married, then we have uh, credit. Let me just copy the names. Loan amount term, copy that, paste that here, and then I'll say credit history. Copy that, paste that here. Okay, so I'll copy this entire thing, Control C, equals to si dot fit underscore transform. Inside the brackets, I'll paste that entire thing. Okay, then I'll say next line, data dot is null dot sum. Uh, what is the problem now? Strategy parameter of simple must be str. Okay, so it should be most frequent, not more, most frequent. Okay, self-employed we have missed, so that is remaining. So let's do that also. Let's include self-employed. Self, then underscore employed. So I need to add here as well. So here I'll say self-employed. All right. So you can see no more missing values in your data. No more missing values in the data. Now, if you just check your data, okay. So let me just print the data here. Data dot head. So you can see loan applicant income, co-applicant income, then loan amount. Okay, all these values are not at a proper scale. Okay, so you have to bring those values on a proper scale. So let's do that. Feature scaling. Feature scaling. Okay, so I'll say from sklearn dot pre-processing import min max scaler. MMS is equals to, I'll copy paste this min max scaler. MMS. Okay. Then in the next line, I'll say MMS MMS dot data is equals to MMS dot data loan amount, then applicant income, then I'll say co-applicant income, co applicant income. So on these three columns, I need to apply feature scaling. So copy that equals to MMS dot fit underscore transform. Paste that. Then just say data dot head. So you can see scaling being applied. Okay, feature scaling is applied. Okay, feature scaling is now applied. Now let's see this. Yeah, just a second. I will also see whether we have created feature encoding. Yes. Okay. Categorical pipeline. Okay. So I'll say feature encoding. Okay. So you can see gender, marital status. Okay, married, gender married. Then we have self-employed, education self-employed, and loan status, property area. All these things are present in text values. So we need to convert them into proper numerical. So let's do that. Okay, so I'll say DIC1 is equals to, I want to replace male with a 0 and female with 1. DIC2, I want to replace marital status, right? So yes, I want to replace that with 1 and 0, no with 0. Then we have DIC3, dictionary 3, so which will be for education column. So I'll say graduate. I want to replace graduate with 0 and not graduate, not graduate with 1. Okay, then let's say DIC3, 4 equals to, so yes, no is already done. So no need to again create that. Property area. So property area, we have 3 values. Urban, I want urban to be 0. Then you have semi-urban, URBAN. So let's check that. How is the value present there? Then you have rural. I want rural to be 2. Okay, so let me just check this. The data of property area dot unique. Okay, so unique. To have urban, rural, and semi-urban. So semi-urban U is small. Yes, one hot encoding. Correct. Correctly identified. So I was just checking that. Okay, so here on this property area column, you have to apply one hot encoding. Okay, fine. So DIC 5, you can just say loan status for loan status. So which is say yes, capital Y, that with 0 and N with 1. Or you can do the reverse. Say no is 0 and yes is 1. So this one, I'll just remove that. This is not needed. All right. So let's say data of, what is that? Data of married and self-employed, comma, self-employed. Okay, equals to uh, data of, just copy that, right? See that, paste it here, dot replace DIC, uh, married, yes and no, right? So we have two. Then data of uh, gender. Gender is equals to data of gender dot replace DIC 1. Then data of uh, education, right? EDUCATION. Education equals to data of education dot replace DIC 3. And finally, we have data of the target column, which is loan status. Loan underscore status equals to data of loan status dot replace DIC 5. Key error. Self-employed, not an index. So self-employed, let's check the spelling. Okay, so self underscore employed. Here also it should be. So now if you just check data dot head, so check that. Everything converted into numerical. Gender, married, married, dependents, education, self-employed, and you can see here loan status as well converted into. So now we need to take care of property area and loan ID.
Excuse me, sir.
Yeah, tell me.
So this property area has only 3 unique values. Now we can also go with this replace function.
No, 3 unique values, but those 3 unique values, if you observe, they are just the names, urban, rural, and there is no order there.
Yes, sir.
So hence, one hot encoding is the only way. So let's say loan ID, loan ID, ID is of no use, hence delete. So I'll say data is equals to data dot drop loan ID, loan underscore ID, my access equals 1. And I'll say data dot head. So you can see data loan ID has been dropped from this data. Now we are only left with this property area. So let's apply one hot encoding. So data underscore OHE, write that. One hot encoding the property area column. So I'll say data of, sorry, data underscore OHE equals to data of, what is that? Property area. So row property underscore area dot, no, pd dot get dummies. Pd dot get underscore dummies And if I just say data underscore OHE. So you can see that rural, semi-urban, and urban. Three columns are created out of that one column, and you can see the one hot encoding. So as you can see, the first row is urban. So urban is 1 and the remaining two are 0. Second row is rural. So rural is 1 and remaining two are 0. So that is how it functions, the rural, the one hot encoding. Now what we do, we join this to our original data. So I'll say data is equals to data pd.concat, pd.concat data comma data underscore OHE and data dot head. So you should be able to see that uh, comma axis equals to 1. This should, yeah. So you see this. The first row is urban. So urban, you can see 1 and rural and this semi-urban is 0. Second row is rural. So you can see rural is this created. Okay. Okay. So it has created two columns, rural and semi-urban. I need to delete this. Let me just do that once again. Or let me just say, I'll just restart and run on. Yeah, it is done, right? No, it is not yet done. Okay. Now check this. So you can see loan status is your target and these three are your rural. So you can see this property area, urban, and urban is 1 in this case. Now, since you have got the one hot encoded values of the property area that are present in your data now, so there is no need of property in your original data. So we can say data dot is equals to data dot drop property underscore area comma axis equals 1. Then it'll say data dot head. So you can see this complete numerical data, no text values, no more text values present in your data. Yes or no? Right? All right. Any questions till here, whatever we have done? No, sir. Fine. So this should be clear. This one should be clear. So now check this. Okay. So now is the place where we create this pipeline. Okay. So I'll just specify automating all the above steps performed. Okay. Using pipeline function from the sklearn library. So how do we do that? So there are few steps that you need to follow to create a pipeline. So let me just write those. Easy for you. Create a steps to create a pipeline. Okay. So first step, okay, or else I'll say step number 1. Step number 1 is just let me write that. Import all the data, okay, all the libraries and functions needed for data. Right now, you just observe this. You will get to know once we apply all these steps one by one. So step number 2, what we do is mention the steps mention the steps needed to perform automation. Okay. And store all the steps in the steps variable. Then step number 3. Step number 3 is import pipeline from sklearn library. Pipeline with the steps variable from steps variable. Okay, so let's understand all these 3 steps. Okay. So step number 1 is saying that importing all the functions and the libraries that are needed to perform data pre-processing. So I will just say, so I'll just say from sklearn, from sklearn dot pre-processing. No, dot import simple imputer. Okay, then I'll say imp equals to simple, sorry, copy paste this function. This, paste it here, function. Then you mention that strategy, strateggy, strategy is equals to median. Okay, so you can mention here at the top that you will be using this. Use this for numerical data. Then I will say use this for categorical data or text data. So from sklearn dot import simple imputer. So you can say si is equals to simple imputer. Copy that, paste that here. Strategy is equals to most frequent. Then I'll say si. Then next what you did is you perform feature scaling. Use this for feature scale. Okay, so right now I'm just doing step number 1. Okay, I'm just importing all the libraries and functions needed for data pre-processing. So we'll say from sklearn dot pre-processing import, okay, min max scaler, mms equals to min max scaler function. Copy that, paste it here, mms. Okay, so now I'll say create the steps variable. I'll just add this here. Mention the steps, or I can say step number 2. Okay, step number 2 that we have written there. What was that step number 2? Mention the steps needed to perform automation. Yeah, so let me just copy this. Okay, let's do that. So steps equals to, I will store that. So just look at the way I'm storing it. Okay. So since there are two steps that I want to perform on numerical data. So what are the two steps? One is missing value treatment and second one is feature scaling. So I will store that in a list. Okay, storing that in a list. So there are two things that I want to perform. So I will create two brackets. Just observe this. In a square bracket, I'm creating two brackets. The two brackets are, one bracket is for missing value treatment and the second one is for uh, scaling. So first I'm creating a layout. Okay, then I will just mention that here missing. Okay, so this is the missing value treatment, MENT, comma. Okay, comma. What you need to specify here is you need to specify the this one SIMP. This, copy this and paste that here. So in the same way, so this is for feature scaling. So for feature scaling, you have used MMS. So just write that MMS here. Instead of missing value treatment, you can say numerical treatment. NUMERI, numerical value treatment. Okay, so it is just a name that you give here. You can give any name that you want. Okay, so steps, say steps. So you can see that. So the steps now contains two things, two steps. One is for numerical value treatment and the other one is for scaling. Now step number 3. Okay, so we'll say step number 3. So step 3, that is, let me just copy that. Okay, so yeah, from sklearn dot pipeline, sklearn dot pipeline, import import pipeline function. Then you say pipe equals to, copy this, paste that here. Okay, this is specifically numerical pipeline. Okay, so since we are including the simple imputer, that is numerical value treatment, and the feature scaling part, so let's name it as numerical pipeline. So you can see this. Yeah, steps. So we did not specify steps here. So steps, my mistake. So just check this. A pipeline is created. A pipeline is created. Okay, a pipeline is created. So now look at this beauty. Okay, now look at the beauty. If I say I'm reading a new data, let's say read the data for March month. March month. So data underscore March equals to pd dot read underscore CSV. Okay. So sorry, the name of that is loan underscore March dot CSV. So loan underscore March dot CSV. So data underscore March dot head. So this is your March. Okay. So exact same thing. See, whatever you have data you have collected in February, the same thing you will be collecting in March also, right? How can we change that? The structure, format, everything will remain the same. So you can see the same thing. Gender ID, sorry, loan ID, gender, married, dependents, etc. and etc. All the things are same. Now, if I just say data underscore pipe equals to pipe dot fit underscore transform. Okay, data underscore March. So if I say data pipe dot head, uh, pipe is not defined. So numerical pipe. So my mistake. How come it says fit transform is not available? This is strange. Value error. Okay, just a second. Transform. Say loan amount. Then we have applicant income. Then we have co-applicant income.
So transform spelling.
TRANSFORM. I think it would work. Okay. Yeah. So see this. What has happened? Okay. So what has happened is, so if I can just show you that in the actual data, let's see that. I could do that. I'm not sure. MARCH. And let's say this is just a second. Okay. Just give me a second. I will show you. I'll just read the data once again and I'll show you. Copy this here. Yeah. So just check this. See this missing value treatment is done. Feature scaling is done directly, automatically. And you can now see that applicant income, co-applicant income, and loan amount all are present in the form of complete all the steps, everything applied at once. So what did you do? You just read the data and you say pipe numerical pipe dot fit underscore transform and everything is done at one shot. Just specify the names of the columns, numerical columns, because we are applying numerical piping. That's it. Are you getting this? Yes or no?
Yes, sir.
Easy or
Yes, sir.
difficult? Others? Once more, sir. What once more? Which part once more? From step 2. Okay. So step 2. This one you're asking? From here, right? Okay, fine. So right now, since I'm explaining it again, so I will just delete everything. Okay. So I'm deleting this cell, everything I am deleting. So let me just show you again. So see this. So as for step number 1, so let me write that. Okay. So step number 1 is just to import all the libraries. Copy that, paste that here. Okay. Of, I'll say numerical data. What I'm saying, import all the libraries and functions necessary or needed for data processing on the numerical data. Okay, so see, you can see this. I'm using this scalar imputer for numerical data. So I have just written that. So simple imputer. This is my library. You can just ignore this. This is for categorical data. Right now, you can just ignore that. No need. Then for feature scaling. So on a numerical data, we perform feature scaling. So you can see that I have imported the feature scaling also. So once you have completely imported all the libraries and the functions for data processing, okay, then the step number 2, you go to step number 2. Step 2, we say it as, let me just copy that. Copy paste. So mention the steps needed to perform automation on numerical data. So specifically, we are looking at numerical only, right? So steps, STPES, steps is equals to, okay. So first you have to create a layout. See, on the numerical data, you want to perform two things. One is missing value treatment, and the second one is min max scaling. So since you want to store two things, you will create a list. Inside that list, you will create two brackets. So one bracket you will specify, in the first bracket you will say numerical missing treatment. So this is just a name. In the quotations you are giving, that is just a name. Okay. Comma, you will specify SIM underscore IMP. So what is this? So missing value treatment you are applying on the data. That is what you are specifying there. In the next bracket. So you are performing feature scaling, or you will say numerical scaling. Numerical scaling. So hence you write that and just mention the function. So MMS. So steps is created. So you can just say numerical steps. So number underscore steps. So you can see that the steps is created. These two steps you want to apply it on the numerical data. That's what you have mentioned. Then step number 3. Step 3. So let me just copy that. So import the pipeline function from sklearn library and create pipeline with the, you can, since you are more specific here, so you can just say numerical underscore steps variable. So say from sklearn dot pipeline import, function name is also pipeline, PIPELLINE. Then what you specify is, so numerical underscore pipe equals, copy that pipeline function, copy that and paste it here. Function. Inside the function, what you need to specify? The numerical steps. So numerical steps, specify that inside this, and then you can say num underscore pipe. This clear up till here? Any questions in this? Clear, right? Okay, all right. Then once the pipeline is created, okay, once you're done creating your pipeline, simple. You just have to read the data. So we'll say read the data for the March month. Okay, so then I'll say data is equals to pd dot read underscore CSV. Data underscore March, I'll say it as. Okay. Right. So loan underscore March dot CSV. Data underscore. So you can see that the March data is also in the same format, having all the same columns like loan ID, gender, married, dependents, education, self-employed. You can see applicant income, okay, and co-applicant income is also there. And you can see loan amount. So all the thing as it is. Now what I do is I apply this pipeline that I've created on the numerical columns like applicant income, co-applicant income, and loan amount. So because I am assuming that there might be some missing values in this. Also, I'm also able to see that the values are not on the proper scale. The scale of the data is not proper. So let's apply that. So I'll say data underscore mar is equals to uh, num numerical underscore pipe, the thing that we have created, dot fit underscore transform data underscore mark. So let me just mention the columns. So loan amount, then comma, applicant income. So let's do it in order. We have applicant income, co-applicant income, and loan amount, right? Say applicant income, UME, then copy that, co-applicant income. Mention that here. And then we have third one, which is loan amount. So copy that amount and mention that here. Okay, this entire thing I'll specify inside the transform, fit underscore transform function. So see this. Okay, so inside this fit underscore transform function, I'm specifying entire thing. Paste that. Now if I do data underscore mar dot head, okay, so you can see that in one shot, everything is applied. Missing value treatment is also done, and feature scaling is also done on the numerical data.
Yes.
Clear? Now on with this. So this is the power of automation. So let's say you have April month data coming in for the April month. Just say numerical underscore pipeline dot fit transform. So let's, for example, you have data underscore April. Right now I don't have it, but I'm just showing you underscore pipe dot fit underscore transform. Okay, and then data. So for May month also you can do the same thing. Data underscore May is equals to new pipe dot fit underscore transform and say data. So May, June, July, August, for all the months you can do that. What was the advantage? The advantage is you don't have to repeat those steps, missing value treatment, and no need of repeating those steps. Okay, now exactly how we have created the numerical pipeline, we have to create the categorical pipeline as well. Categorical or text, we can say create a pipeline or categorical. So let me just show you before this, let me just show you a shortcut as well. Okay, so look at this. See, in the step number 3, okay, so here only I'll add that step. Shortcut method for step number 2 and step number 3. See, you have followed 3 steps here, right? So step number 2 and step number 3. So if you want to do both of these steps in one single step, okay. So no, if you don't want to create two steps like this, just one step if you want to do. So what you can do is from sklearn dot pipeline, you can say import make, sorry, what was that function name? Just a second, I'm just checking that. Make underscore pipeline. Make underscore pipeline. Yeah, so it is make underscore pipeline. Then you can say here numerical underscore pipe equals copy paste this thing. Okay, then you can specify your steps. So like, and say SIM IMP. You can also mention MMS. So this also works fine. So you can say numerical pipe. So see that. Okay, you can just remove this. List is not needed. Yeah, so see this. So both steps done in one single steps. Okay, instead of creating two steps like this, like creating a name for that. Okay, naming that. No need of doing all those. And just say this and apply that on the date. It's up to you. However, you so what I will suggest is, so if you are still beginning in the beginning phase, so just follow these steps. Once you are comfortable with that, then you can go with this step number, this shortcut method. Okay. But my thing will be learn this shortcut method is also very much required. I mean, easy, right? Number of codes, lines will be less. So get a practice of this, hang of this. Before that. Okay. So clear with this. Any questions in this one? Just the name is different. That's it. Nothing new in that. Instead of pipeline, you are using make pipeline function. And inside the make pipeline function, you are directly specifying the steps. Nothing new in that. Shall I repeat that again or clear? This
Also
one,
clear.
cell number 41. Yeah, Abhishek says clear. What about others? Yeah, it is clear, right? Okay, all right, fine. Yeah. So nothing new in this. Okay. I have not done anything new. I have just specified instead of pipeline. See, if you just look at this, instead of pipeline function, we are specifying the make pipeline and using that and just specifying the steps here. So simple imputer, this is for uh, missing value treatment. MMS is for feature scaling. Directly, we are specifying in that make pipeline function. As simple as that. Create a categorical pipeline. So we'll say we are creating the categorical pipeline. Okay. So let us say, yes, Rajalakshmi, you want to say something? Okay. So missing value treatment on the, no, sir, nothing. Yeah, fine. Missing value treatment on the categorical data. Categorical data. So we'll say from, yeah, so you have to import all the libraries, right? So I'll just write that as well. Yeah, step number one. Step number one is to import all the libraries and functions necessary for performing data preprocessing. Okay, so let's execute this. Then we'll say from sklearn dot uh, import simple imputer. I'll say sim si is equals to simple imputer. See that, paste that here. Strategy equals to most free. most frequent. Then we'll say SI. The next step that we have to do is encoding. Encoding the categorical data. So from sklearn dot preprocessing, I think spelling is right? Preprocessing. Uh, Copy this processing spelling. Yeah. Okay. PRO. Huh. Import one hot encode. OHE is equals to, copy that, is that here, say the function. So with that, you can see that one hot encoder is also imported. Now in the second step, we define the steps. Okay, so step number 2, define the steps for categorical, what is that? Categorical pipeline, and store it in cat underscore steps variable. So you can say cat underscore steps equals, yeah, so missing value. So 2 steps again. So again, same way, create the layout first. Inside this, specify cat missing treatment, and then specify that SI. What is SI? SI is this one. Okay, that I've created. And then again, same thing. So mention encoding. So say one odd encoding. You can specify OH. So you can say cat steps. So you can see that cat missing treatment, cat steps, and then step number 3 will be to create the pipeline. Step number 3 is to create the pipeline. Okay, create the pipeline for the categorical columns. On from sklearn dot pipeline import pipeline. Okay, sklearn dot pipeline import pipeline. Cat underscore pipe equals, okay, cat pipeline, pipeline. Inside that, you specify cat underscore steps. Cat underscore pipe. So that is, you can see that. All right. Now what we do is, so let me just show you that. We apply it on the data. Okay. So we'll say, see this. Apply the categorical cat pipe on the March data. So if you see your March data, if it is like this now. Sorry, data underscore March. Yeah, so see this. It is like this. So you have male, married, graduate. Okay, all text values are present. Everything is like this. Then what we do is we'll say data underscore March. No, data underscore pipe is, yeah, equals to pipe dot, no, not pipe. So it is categorical, right? So let me just cat pipe dot fit underscore transform. Data underscore March. Inside this, specify all the column names. So you have gender, you have married, you have education, okay. Then you have, anyways, if you want to apply one hot encoding, you can directly apply it on this one. Okay, so can specify only one column name as of now. Property area. ROPERT, property underscore area. All right. So data underscore cat underscore pipe. If you do this, you'll get some odd output. So if you want to check or get a proper output, you will say data underscore cat underscore pipe dot to array. So you can see that this is your rural, this is your semi-urban, and this is your urban. Okay. The output, one hot encoding is done, but it is present in the form of an array. If you want to convert that into a proper data frame, so you can just do this. Data underscore OH is equals to PD dot data frame. Copy paste this entire thing. Copy that, paste that here, and say columns equals rural, semi-urban, and then urban. OH. So you can see this. Now join with this your original data. This one you have to join with your original data. So you can say data underscore March is equals to data pd dot concat, pd dot concat data underscore March, comma data underscore OHE axis equals 1. Data underscore March dot head. So you should be able to see that. So see this. Rural, semi-urban, urban. It is now present here. Is this clear? Yes or no? Scroll up. Okay. Done. Okay. Any questions in this? Not done, sir. Okay, not done. Okay. 50th line. All right. One scroll up for step 2. Okay. Once scroll up for step 2. Done, sir. Okay. So this cell number 50, you can take the cell number 50. Done everything. Okay, fine. So now check this. So this entire thing, you can now see you have created a numerical pipeline, you have created a categorical pipeline. Now you can apply it on any amount of data. Okay, so steps are automated. So now steps are automated. Okay. Now next what you can do is, see, let me write that. You have, just give me a second. Yeah, so you have automated these steps, right? Automated the data pre-processing steps. Data pre-processing steps, right? Using what we say, numerical pipeline and categorical pipeline, right? We have automated these steps. Now, these pipelines that you have created, again, you can automate those also. What I'm saying is automation on automation. So you can also automate the pipelines as well. So how do we do that is using a function called as column transform. The first thing is automating the steps. Okay, all the data pre-processing steps, you automate that using the pipeline functions. Now, pipelines also can be automated. What I'm saying is, see, if you just observe or if you just have noticed the above steps here, so we have created two steps, right? We have created two pipelines. One is the numerical pipeline and one is the categorical pipeline. So when a new data is loaded, so let's say data underscore April, if you load the data underscore April, then what you have to do? You have to say data underscore April, numerical underscore pipe dot fit underscore transform. Okay, and then you'll say data underscore April, right? So this is what you do. This is for numerical data. Then next what you do, data underscore April is equals to numerical, sorry, categorical underscore pipe dot fit underscore transform data underscore April. So in the same way, you will do it for May, you will do it for June. So again, what you have to notice here is you are applying two pipes. One is your numerical pipeline, one is your categorical pipeline on the data. Now, instead of these two lines, what you can do is and just say data underscore April equals to categorical, no, column. So I'm just giving you layout. Just don't consider this as your final thing. Just telling you how it looks like. Column, let's say underscore transformer of data underscore April. So if you do this, the numerical pipeline also will be applied. The categorical pipeline will be automatically applied. So you will get the final, this result you will get. No need to write numerical pipeline, categorical pipeline on the data separately. Are you getting this logic? Yes or no? What I'm trying to say. Yes or no? Yes. Others,
Yes, sir.
right? Okay. So it is like automation on an already performed automation. So first you have automated the steps using numerical and categorical pipeline, using the pipeline function basically. And pipelines, again, you can automate that using the column transformer function. So I will show you that. Okay, I'll show you that. I think it's difficult to complete that. So let me just see if we can do that. Give me a second. Okay, all right. So let's do it. Okay, so I'll just say create a column transformer using a column transformer for pipe and categorical pipe. So let's see that how to do that. Okay, so to create a column transformer, you have to follow these steps. So let me just write the steps first. To create the column transformer, follow the below steps. So first step, uh, step one, separate all numerical and categorical variables. Categorical variables. So let me just see that. Okay. Then step two. Okay. So step number two is create a column transformation pipeline. And then step number three is apply. Apply the column transformer. Okay. So I'll just say column transform. Apply the column transformer on the data. These three steps become very important to you. So let's do that. Okay. So let's do that. So first step, uh, so step number one, step one, as we have written there. So it is to separate, copy that. Paste it here. So I'll say data. Okay. First, I'll read that. Just a second. Or here, we'll just read the data here. Data underscore March is equals to PD dot read underscore CSV. So this is your loan underscore March dot CSV. So this should be your data, raw data, right? So which is having all numerical values you can see here, and you can also find that property area is not one hot encode. So separate. First step is to separate the data, right? So I'll say numerical underscore features equals to. So numerical features are applicant income, income. Then we have second one as your co-applicant income. And then you have third one, which is your loan amount. Then categorical features equals to, so you just specify that. Let's say property underscore area. All right. So these are your separation of numerical and categorical variables separated. Okay. The next step number two. Uh, step number step two is create the column transformer. So let's do that. So from sklearn dot okay dot compose import column transformer. The function name itself is column transformer, and where it is imported from the sklearn compose library. Okay. So we can say call underscore trans equals to column transformer. Copy that, copy that, and paste that here. Okay, copy that and paste that here. Inside this, what you need to specify. So let's check. Okay. You need to specify two things. What are the two things? We have written that already here. See this. You can automate the pipeline as well using the function column transform. So what are the column transformer function should include? It should include the numerical pipeline and the categorical pipeline. So that is what we need to specify in this. So like look at this. Okay, create a list. I'll create two things. Yeah, so see this. So I'll specify that numerical pipeline. Okay, so if you know that the numerical pipeline name is num underscore pipe. Where this is coming from? So just look at this. It is coming from here. From here. Yes, this one. This is your numerical pipeline that you have already created, right? So that is what I'm specifying there. See this. Numerical pipeline, num underscore pipe. Same way you have to specify for category. So categorical pipeline. So you can say cat, no, cat underscore pipe. Done. This is the only two things that you have to specify inside your column transformer function. You can say call underscore trans. So see that what your column transformer contains. So it contains numerical pipeline. So pipeline is having those two steps, simple imputer and MMS. And then your categorical pipeline contains simple imputer strategy and this one hot encoding function. Okay, it gives you the complete picture of the column transfer. Now your job is just to say call underscore trans. Okay, let's say TRA data, right? data underscore March is equals to, and say call underscore trans dot fit underscore transform. Okay, fit underscore transform data underscore March. Inside the brackets, specify the column names. So I think it will not do that. Just a second. Not enough values to unpack. Expected 3 got 2. Okay, so what do we do is, okay, my mistake. We need to add one more thing. I just missed this. NUM underscore features. Here, cat underscore features. Just make a note of this. What I missed in this part is, in the column transformer, you need to specify the numerical and the categorical features. See, if you don't specify, then what is the use of step 1, right? We are separating out this numerical and categorical feature just because of this thing. So if you don't have apply this here, then what is the use of that? So let's do this. Value error again. Data all trans fit underscore transform fit underscore transform data underscore March. So data underscore March is the one I have read it here. Yeah, give me the output. Features. Let me just do this. Cat underscore features. Type error. Why it is giving me error suddenly? Matchable type list. A second. See what is the error. Invalid index error. Not enough values to unpack. Expected 3, got 2. What is this? This is strange. So data underscore March is equals to. Okay, let's say just data underscore call once. So data, sorry, call once dot, it's called transfer, right? Yeah. Fit underscore transform data underscore March. Oh no, not enough values to unpack. Expected 3, got 2. Where I have specified 3, I have not specified 3 at all. This is a sudden error at the last one. Yeah, but the way is the steps are correct. Don't worry. I need to see where am I doing the mistake. In line number 61, fit transform data underscore marks, validate transform or enough values to unpack. Expected 3, got 2. Value error. Okay. Where it is expecting 3. Column transformer is perfectly fine. Data march. Hmm. Numerical features. Comma cat features. No, no. FEAT. Okay, fine. So I think there is some error. I need to fix it. I'll need time to fix this error. Check where am I going. But if you do this, it will apply the both pipelines. So you don't have to again separately apply numerical pipeline, separately apply categorical pipeline on the data. Where am I going mistake? Where am I? All right, fine. So I'll show you this tomorrow only. Okay, it's already 3 minutes only left. If I spend time in correcting the errors, then it will not be. Anyways, any questions or any problems, any doubts anywhere? You can let me know. Multiple regression pending. Multiple regression. Yeah, I have done it on Saturday. That's why I told you. Record. Yeah, watch Saturday's recording. It is done on Saturday. Saturday, we have completed multiple logistic regression. We have completed 2 more new concepts. Yeah, absent on Saturday. So please watch Saturday's recording. Okay, so I have covered 2 more new concepts there on Saturday. So let me just tell you what I have covered on Saturday. So I have covered, yeah, I have covered how to increase accuracy. What is k-fold cross validation? How to increase accuracy using cross validation score function and all was covered on Saturday. Okay, so please go through that recording. Assignment to extend deadline. When is the deadline?
Today, sir.
Today. Let me just check that. So what is the problem in assignment 2? Why do you want an extension there?
Like one of the data sets it is not get downloaded.
One of the data sets is not getting downloaded. Which one?
Fourth, sir. Fourth.
House price prediction.
Yeah.
So everyone facing the same problem.
Yes, sir.
How are you downloading that? I mean, let me just show you the screen. So you are downloading this train data, test data only, right? It is not getting downloaded, you are saying. Let me just see that if it is downloading or not downloading. Okay. Okay, you have to join the competition probably. Then you will be able to allow to download the data. All right, I'll extend that. Any other questions?
No, sir.
Others? All clear? Yeah, so by tomorrow, please go through to Saturday's recordings. Okay. Saturday, there were very less people. go through Saturday's recordings. So we have covered multiple logistic regression, cross validation score, k-fold cross validation, and model selection. How to select the best model and all those things have been done on Saturday. So please go through that. Okay, fine. All right. So I'll be just closing this
Excuse me,
here.
sir.
Yeah, tell me, Abhishek.
Sir, please extend the deadline of quiz 6 because we have covered the topic today. Column transformer.
Okay. Quiz 6. Till Wednesday, I'll give. Okay, not more than that. So it is 31, na? Quiz 6. 31st is the due date.
Before only extended, sir.
It is extended. So,
Yes, sir. In morning I saw that
okay.
it's not
Okay.
action. Yeah.
All right. Fine. So, done. Fine. So, we'll meet again tomorrow. Same time, 7:30 in the evening. Okay. Bye bye.
Thank you, sir. Good evening.
Sir,
Good
good
night.
night.
Good night.
Thank you, sir.
Thank you, sir.
Good night, Uncle. Sir, Uncle.